Hello test takers, welcome back to Exam Prep Solutions. We have another practice problem. This one's going to be focusing on water resources, but the environmental side of it. You will get a few environmental engineering questions on the FE exam, and this is a possible one you might see. This is about BOD, or biochemical oxygen demand. So let's get into this problem. We have a free guide, the 5 steps to solving any FE exam problem. So we have a 5-step guide. Go to the description box. You can get that 100% free. Gives you a nice blueprint there. Anyways, given the ultimate BOD is 25 milligrams per liter and the BOD at day 1 equals 2 milligrams per liter, find the BOD at day 10. So we're going to be using this BOD exertion equation to help us find that BOD mark at day 10. So BOD sub t is the amount of BOD exerted at time t. We're going to be using that some of that information so we can find the K value, which is the BOD decay rate constant, which they didn't give us. So given that the BOD at day 1 equals 2, we're going to go there, and then the ultimate BOD is 25, and that's going to be multiplied 1 minus e raised to the negative kt. And so now we know that we actually don't know the k value. We know t at this point is actually 1. So this is the setup for our equation, and we're going to solve for k. So we got to do 2 divided by 25, that equals 0.08. So 0.08 equals 1 minus e raised to the negative k. That's what we have here so far. So now we can subtract the 1 to the other side, times by negative 1, so we get essentially 0.92 equals e raised to the negative k here. And then if we use our calculators, we can take the natural log of both sides of this equation. Remember, that is the inverse of e in this case. So the natural log of 0.92 is what we're going to want to put in next. So natural log 0.92 equals negative 0.083. And that's what our k value is going to be, or actually it's just going to be 0.083 because now we have negative k equals negative 0.083. So k equals 0.083. So now we have our k constant. We can now find the BOD at day 10. So the BOD t is what we're solving for here. Next, same thing. The ultimate BOD has not changed. And we're going to go 1 minus e raised to the negative k, so negative 0.083. But now the time is 10 because it's 10 days into, we're trying to find BOD at day 10 is the time interval we're looking at here. So now we have 25 times 1 minus e raised to the negative 0.83. And that is our equation right now. That's what we're going to be able to find, BOD sub t. Okay, and let's start calculating out these values here. So e raised to the negative 0.83, we're just going to put that in our calculators here real quick. And that equals 0.436. So we can go 1 minus 0.436 equals 0.564 times 25. Here, I'll do this. So 25 times 0.564. That's going to equal 14.1. So BOD at time t equals 14.1. That was 10 days into the test. And so we're going to be looking at answer A here. So how did we solve this problem? Pretty straightforward. We used this BOD equation to find the BOD decay rate constant because we had the ultimate BOD, we had the BOD at day 1. And then we used that decay constant to then find the BOD at day 10. So if you have any questions about that problem, leave it in a comment down below. If you have any problem suggestions, you can also leave it in a comment there. Remember, we have our guide, 5 steps to solving any FE exam problem. Anyways, we'll see you guys in the next video.